In this video, we're going to look at metric stats where we're working with scatterplots and lines of best fit. And so typically you'll get two sets of information like we've got in the question here of fats in grams, which is like our x-axis, and energy in kilojoules, which is like our y-axis. And so to input the data, you're going to just go mode, choose stats, and then choose the option that is as follows: a plus bx. Then you're going to type in all the information. So these will be all your x's, these will be all your y's, and then you press AC, which makes you feel a bit nervous because it clears all your information away. But then when you want to use the information, you're going to press Shift 1 and option, it depends what your calculator is, but the option that's reg for regression line. And then if you needed A, then you'd press A and it would have spat out that answer. If you cleared that, so you went AC again and went Shift 1 for stats and you chose regression and you chose B, that will give you the gradient of the regression line, B. And the other most common thing that we're going to get is R, doing the same process but choosing R, which is your correlation coefficient. And so if I were you, I would pause this video at this stage and just input all the data and see that you get this least squares regression line. And plotting the information, I think it's pretty chilled. This is just the X value, so I'll give you one example. 9 across, that's about there, and 1100 up, so that's the first point, and you'll do the same for all of them. Then your calculator is pretty much going to get, like I've just explained, the line of best fit, the least squares regression line for you, and you use that to predict. So if I needed an item at a restaurant contains 18 grams of fat, and that's my X, I'm just going to put 18 into the equation, and that will give me an answer of roughly 1,500 kilojoules, because they want us to round off to the nearest 100 kilojoules. Drawing the least squares regression line, this basically acts as your y-intercept. For me, I would probably sub in an x value just so that I have another point, because it will churn out a y value. And so you might choose something like 20. So sub in 20 into the equation, see what it spits out as your y value, and then you can plot that point. So that's roughly here. And once you've got that point and you've got your y-intercept, you can draw your least squares regression line. Then identify the outlier. Typically it's the information that's far away from all the rest of the data, and so that would be, in this case, fairly obviously this point, which is 8 across and 300 up. So there is my outlier. You can write it as a coordinate. Calculating the value of the correlation coefficient, same process I said earlier. We're going to use our calculators, choosing reg and R, and in this case, we've got an answer of 0.95. That is a very, very strong positive correlation, just to answer the next question as well. If it is 1, that's as strong as you can get. If it's -1, that's negatively as strong as you can get. But anything that tends to 0 is weaker. And what that means is that this question is a really good, because of the high correlation, it's a really good predictor of trends. And so with confidence, I can be subbing in values either coming from the y-axis with energy to work out the fat, or the x-axis fat to work out the energy. So this answer, to finish off the question, would be a strong positive relationship. I hope you found this video and this example helpful. If you did, please like this video, subscribe to our channel, and share it with your friends.